Now, it's also common to get show that questions. Now, a show that question literally starts by saying, show that. Now, this means they're going to give you the answer because they're telling you what they're wanting you to find. But what you need to do to get the marks is actually show all of the steps that lead you to that point. Now, the fact that they're telling you where you should finish is a really good clue, so that if you get a little bit stuck, you can look at that and think, well, what do I need to do to perhaps get there? The other thing to do with these sorts of questions is always just look for clues in the question itself that's going to help you. So this one says a cylindrical soft drink can must have a volume of 250 cubic centimetres. So we're talking about volume. Obviously you need to put 250 mils into this can, and that's why it needs to be that size. Now, a quick sketch of a cylinder to remind you of all the formulas that you know about cylinders is going to help. Now, the first question says, show that the height of the can is 250 over pi r squared, where r is the radius of the base. So we've got the radius here, we've got the height. Now, if we've been told what the volume is, that's our first clue as to where to start. So I begin by actually just writing the volume of a cylinder, and it's pi r squared for the area of the circle on the bottom, multiplied by the height. Now, if we've been told what the volume is, we can replace V with 250 and rewrite the rest. And then looking at what it is we're trying to show that the height is a certain thing. So we obviously need to get the h by itself. So to get the h on its own here, I need to divide by pi r squared on both sides, so that the h will equal 250 over pi r squared. And now I can tell I've finished because I've got the thing that they've asked me to show, but if this was a 2-mark question, if this was a 2-mark question, I would literally get my marks for this first line and this second line with the substitution. For B, I need to show that the surface area is equal to this. So I'd start by saying, well, what is the surface area of a cylinder? I know the formula. It has pi r squared on the top, pi r squared on the bottom, so that's 2 pi r squared. And then when you fold out a cylinder, you get a net that looks something like this, where this distance along here of the curvy part has to actually wrap around the base. So that makes it the same thing as the circumference, which is 2 pi r, and this part's the height. So the area of this section is 2 pi r h. Now that's just a basic old formula for the surface area of a cylinder. Next step is I need to say, well, how am I going to make mine look like this? They've got 2 pi r squared plus something else. So obviously I need to readjust this. Now when you're feeling stuck in a question like this, think to yourself, well, what clues have I got? I'm in part B. What did they give me in part A? Because often that's exactly what you need to help you. So in part A, I came up with this expression for h. And that's a good clue that what I'm going to need to do here is sub in that expression for h. So I'll have 2 pi r times my expression for h. Now, here's a hot tip. If you couldn't solve A, you weren't sure what to do, because it's a show that question, they've already given you this expression for h. So even if you didn't complete part A and you got no marks for it, you can use their information to solve part B, and so on and so on. Now here I can see that I can cancel the pi's, and I've got an r here, and I can get rid of one of the r's down the bottom, and that gives me 2 lots of 250, that'll be my 500, with an r on the bottom. So finish it off, and we've shown how we got the r. So they're looking for that cancelling, almost like you're proving that this is true. Now for part C, I might just rub this out so I've got a bit more space on the board. In part C, we want to show that the radius is equal to a certain thing, and we need to show that that gives the minimum surface area. So since we're dealing with surface area, we're going to want to start with this expression here for the surface area. And again, if you couldn't show that, they've given it to you. You can use that in part C. So I'd start by saying surface area is equal to 2 pi r squared plus 500 over r. So if I want to minimise the surface area, that means I want to find, when I graph surface area with respect to the radius, I want to find the minimum value of that. In other words, the minimum turning point. And that will tell me what the smallest radius, what the radius will be to make the smallest possible surface area. So I need to differentiate with respect to r. Now that's quite simple to do here. I just bring the 2 down the front. I've got 4 pi r. This section here would be easier to rewrite as 500 r to the minus 1. So you could have actually written it that way as you put it down in the first place. And now differentiating the minus 1 comes down, and we've got r to the minus 2. So another way to write that would be 4 pi r minus 500 over r squared. Now if I'm going to let that equal 0, and the reason I want to let it equal 0 is so I can find any stationary points, because that's where we'll find the minimum, then that means I could let 4 pi r equal 500 over r squared. Now multiplying both sides by r squared, I get 4 pi r cubed is equal to 500. Divide both sides by 4. And now to get the r by itself, I can divide both sides by pi. And now to find what r is, obviously I need to take the cubed root of this. Now the cubed root of 125 is 5, and the cubed root of pi, well that gives us this cubed root of pi. So I've shown what I've been asked to show, one step at a time, and notice that I didn't leave any steps out. If you just had to minimise the surface area and prove what the radius is, you might have left out 1 or 2 of these steps and just sort of done a little bit of it in your head. But with a show that question, you want to put every step down, because it's almost like a proof of how you got there. It's not enough to get halfway and then cut straight to the end. After all, they gave you the end point, so that doesn't really prove that you knew what you were doing. So then we can see that this value of r is special in that it allows us to find an actual stationary point on S. But what it doesn't do is confirm whether or not it's a minimum. So it does say here to confirm whether this is a minimum or not. So really we should find the second derivative and confirm that it is in fact positive, because if it is positive we'll have concave up and our stationary point will be a minimum. So differentiating this again with respect to r, we get 4 pi, and then bringing our minus 2 down here and multiplying out, we get plus 1000 r to the minus 3, which is the same as putting our r cubed down there. Now think about what r is. R is the radius. Can it be negative? No, it's a distance, it's a length. So that means if r is definitely positive, r cubed will also be positive. And 4 pi, that's a positive number, plus a positive divided by a positive, we're going to have this being positive all the time, which we can write, which is positive for all r. Now if it's positive, therefore it is concave up, and we can confirm that this is a minimum turning point. Now in part D, we need to show that to minimise surface area, which we've already just done in part C, the height should equal the diameter of the base. Now the diameter of the base is 2 radii. So we can use this expression that we already have for the radius, which gives the minimum surface area, and say, we know that h is equal to this. Let's move all the way back to A. We were told that h is equal to 250 over pi r squared. So when the radius is equal to 5 over pi, the cubed root of pi, now I'm going to write that pi to the power of a third, because when I play around with my indices here, it might just be a little bit easier to work with. When r is equal to that, what's h? Well, subbing this into h, where the r is, we've got 250. Now instead of putting a divide by like this, I can see that I'm going to be dividing by a fraction, so I think it's easier to put divide by and then make my fraction here, and then I can times and flip on the next step. I need to divide by pi times the radius squared. Now this is the radius, so when I square it, let's just do things one step at a time. I've got pi to the power of a third, and I need to square that whole thing. So that's equal to 250 divided by pi times, now we've got 25 on the top, and on the bottom, if we square this, we get pi to the power of 2/3. Okay, now you can see that we've got pi's here and here. This is really pi to the power of 1, isn't it? So if you've got pi to the power of 1 divided by pi to the power of 2/3, then that's pi to the power of 1 minus 2/3, which is pi to the power of 1/3. So we've got 250 divided by 25 pi to the power of 1/3. Now, that's going to give you the same thing as if you wrote it like this. And now we can see that we can cancel here and get 10 on the top. So we've got 10 over pi to the power of 1/3. Now let's compare that to the radius. Is it double? Yes, because we've got our pi to the power of 1/3, but there's a 5 on top. This one's got a 10 on top, so it's literally just doubled. So at that point you could write which is 2 times the radius.